So what sort of object are we dealing with if we're looking at something that says, for instance, x equals 3? Now, x equals 3, it depends on the setting that you're in. If you are talking about the x and y axis, which is just 2 dimensions, then x equals 3 is going to produce a vertical line, which has 2 dimensions. So in the xy setting, in the 2-dimensional setting, x equals 3 produces a line where you have many different points strung together with one thing in common. All of these points have one thing in common. They all have an x coordinate of 3. The y coordinate is free to be any number in the world that is real, as long as the x coordinate is 3. But that's in 2 dimensions. If we are talking about 3 dimensions, then the object x equals 3 takes on a whole different meaning. Because here in space, x equals 3, which let's say 1, 2, 3. Here at 3, it's not just the line. It's not just a point. We actually get back something that we call a plane, where in a moment I'm going to use my computer because I am not an artist, but if I tried to do a terrible job here of drawing something, it's as if I had another sheet of paper, and you see that slot there? It's almost as if I could take this paper and slide it in to x equals 3, slide it in there, but just pretend that this piece of paper goes forever in every which direction, left, right, up, and down, I should say. So, gosh, do I even dare draw something like this? Okay, it's essentially gonna look like this, where this blue plane is slicing through x equals 3. So let's rely on a computer generator, a grapher, to see this in detail. So let me just hold my phone here. Now I have here GeoGebra, which is a really cool 3D graphing calculator. And up here, let me graph x equals 3, which is what we discussed a moment ago. And you'll see that we have a plane. And what's cool is I can just go like this. You see that? So that's what I'm talking about. It's like what color is that? Like neon blue, neon green, whatever color that is. So it's like turquoise-ish. So let me reset this. So here we have the x-axis, the y-axis, and the z-axis, which is typically how I like to draw it. And then as we said, x equals 3. In this setting, it produces a plane. P-L-A-N-E, plane. And if I just go like this, you can see that there are many points that live on this plane. And every point on this plane has an x coordinate of 3. The y coordinate and the z coordinate can be like whatever, right? Positive, negative, 0, whatever. But every x coordinate on this blue turquoise sheet of paper or plane is an x coordinate of 3. So what kind of shape is this? It is a plane. How about a different one? Instead of x equals 3, how about like y equals -2 or something like that? Y equals negative, let's go with -5. So now, if I hit enter, now you can see that the plane is way back there, right? You see that? Every point on that plane has a y coordinate of -5. The x coordinate and the z coordinate, those can be, just about anything. The y coordinate of every point on this plane is -5. What about something different? What about something like y equals, let's say, x? Hit enter. Let's reset this. So consider a graph that says this, y equals x. So we get back another plane, but you have to really know and understand the properties of this plane. What is special about this plane? What's going on here? Well, this plane is such that every point that you could possibly choose from this plane has the property that the x and y coordinate are the same. So for instance, something like a 5, 5, -6. That point is somewhere on that plane. Something like, let's say, -100, -100 pi. That's a point. And I guarantee you that it's somewhere on this plane. So that might be a bit dramatic, but how about something a little smaller? -10, -10 pi. Let's actually try to plot that here on GeoGebra. Actually, I typed it in right there. Let me focus the camera. So you can see here where the mouse is, -10 pi has been typed in. And I don't see it, but I have to zoom out. And if I zoom out, there it is. That point is actually on that plane, because if I just go like this, you can see that the point is on the plane. Boom, right there. That's a pretty good view. So the equation y equals x in this setting is actually something that produces a plane, and that plane has the properties such that every point on the plane has the x and y coordinate identical, and the z coordinate can be anything that is real.